So if you put more than one negative in there, you made a mistake.
What's confusing me here with 2's over there? So you added the 3 2's together to get 6?
Oh, here, the 2's. Yeah. What do you do when you multiply w squared by w4? You add the exponents, right? Add exponents when you multiply.
Oh, okay.
Cool.
Oh, okay.
All right, cool. So that's a little review. But that's the cubes, guys, the one that if I were you, I'd just do every now and again, and I would do a few of them right before a test. Just to keep it kind, because it's all about having the pattern in your head. The more you do them, the more it sticks in your head.
It's a lot easier than trying to remember the formulas.
Like A plus
No, it could be here too, but I really just don't teach it that way. Some people do like that. I mean, some people, I've noticed, some students do like, you know, if I have something cubed plus something cubed. And if we, let's just attack it. What would go on the little guy?
A plus B.
Yeah, 1A and 1B. The other 2 A's, the other 2 B's,
A squared.
minus AB.
Same thing.
But now, here, A is 4W squared. Because that's what I cubed to get 64W6, isn't it? 4W squared, 4W squared. So you can put a 4W squared everywhere you see an A, you can put a 4W squared. Everywhere you see a B, you could put a 3Y. That's basically what I do. I just noticed that fewer people understand it this way than understand it just directly. But some of you guys might understand it this way, where you just plug in what B and A are for my specific situation. This is more of a form argument. It's got to be in this form. Whereas me, I do more of a build argument. Build what goes in there based on what you got, right? More people like this, that's why I teach this way. Not as many, but a few people do like this. And that's in the book. So. This also explains why the middle dudes won't ever factor, because you need a 2 there for it to factor. And like I said earlier, the middle, this is always going to be half of what you need. That's why it won't factor. Okay.
Maybe.
So that's the answer.
So yeah, that's how you factor this. And I just load it with crap, right? The thing to remember is don't waste time. I know that's 3 terms, but it will never factor like I just said. The big dude will never factor unless there's a GCF you accidentally left in there, right? Otherwise, this will never factor like a trinomial. Don't waste time trying to do this. That's just a waste of time.
That's the end answer?
That's the end answer, yes.
Okay, thank you.
Because there's no GCF, right? Okay, maybe.
Maybe.
Wow.
Maybe not.
Maybe not.
I mean, you know, I try to get you guys to understand the process, but the reason we do this is because so many of our equations have these. If I'm able to do this, maybe this will cancel somewhere. Like we see in section 6.1 and 6.3 now. And then I can have a much easier function to work with. Do you want that? I want that. I want an easier freaking function. Right? I don't know how to simplify my functions unless I know how to factor them. Right? Okay. I hope you notice something. The better you are with section 6.1, 6.3 is really the same thing. Isn't 6.3 the same as 6.1? It just has this extra little dude sitting here.
Yeah.
6.1 you factor, kill. 6.3 you factor, kill. If everything will factor, right? It's the same thing.
6.1
division, be careful, you gotta reciprocate it, but we know how to divide fractions.
6.1 has a better ring to it than 6.3.
After you break it down.
And then you break it down. So here, try,
Well, can you do it either way though? Like that, like break it all down and then
reciprocate. Yeah, that's fine. As long as you don't forget to turn it over. Try out this one here. For some reason they make this a big deal. Look at number 57. Yeah. Yep.
That's like
Not y minus 3, y minus 4, y plus 3?
Mm-hmm.
Okay.
that's like it's over 1.
Good. So one thing to realize is this is over 1. That might help out to balance things out a little bit, right? That's one reason they give you this problem is to see if you notice that, or if that even bothers you.
Wow.
It really shouldn't bother you, but if it does, you can put it down. Right?
I have issues with that.
Bother me problem. Take it way back. Get away from me. Get your
So that second one on the bottom is
Don't forget the negatives.
minus.
Yeah, so this is not too bad, right?
Yeah.
Just want to show you, they're going to give you some that are missing a bottom. You can just put it over 1 if you want to balance it. And it's the same way. So here,
Minus 3 plus 3.
and all this crap here again, right? So the y plus 3 and the y minus 3.
They cancel.
Why am I allowed to cancel those now? Because now I only have multiplication and division. So now they'll cancel. And what's left alive here?
Minus 1 minus 1.
There's a negative 1
Uh-huh.
and
Y minus
a y minus 4, and on the bottom there's only a 1 left there, right?
Oh, yeah.
Is that cool?
Yeah.
And you can write this instead, how negative 1 times negative 4 is positive 4, negative 1 times y is minus y. Either one of those I'll take, right? They're both the same.
I leave it minus 1 up.
That's fine.
Minus y plus 4.
You have a preference?
You could, but that you definitely don't really need. But if you left it there, it wouldn't bother.
Do you have a preference as to which one we write? Negative 1 times 1 minus
No.
4 is 4 minus 1?
No. The reason I'm okay with this is because this section is all about factoring. And if you leave your answer in factored form, most of the time that's better. If you leave it factored, you can see that nothing else goes. And that's actually something I don't think I've said really here. Let me see. That's not a good example of this. Let me give you one more example. I mean, look at number, let's do this one together just to show you what you can possibly see in this section. Number, what number is that, Jeff? I don't know. What, Jeff? I don't know. 33, look at that thing. Page 494.
33?
Yep.
Jesus Christ.
So this is what you guys do to yourselves. You look at a problem like that, and you look at it all at once.
And it turns into a God help me problem.
To help yourself out, to be better at math. When I see, when I look at that, I first take the whole thing in, sure, and I go, oh shit. But then I say, I see what kind of problem it is, and then all I see is a squared minus 16b squared, because that's the first thing I worry about. Right?
You take a step at a time, don't you?
So drive crazy.
Really?
Okay, good. So that very first little piece here, you see there's like 3 things going on here. What's that a squared minus 16b squared?
B minus 4b, a plus 4b.
Right? And then you work your way through. So it's the same thing I said before. If you're able to break a problem down into its parts, math is so much easier. But as a math student, it's too easy to look at a whole problem and go, oh my freaking God. But really, the first thing is easy. It's a thank God problem. It's a little tiny difference of squares. What about the bottom there? That's pretty easy too, actually.
It's a minus 4b.
Yeah.
A minus 4b.
Because it's only 4 and 4 make 16. They both have to be negative to make negative 8, right? A minus 4b
A minus 4b.
times, over here, really the same kind of thing, right? What makes 20 and adds to be negative 9?
4 and 5.
4 and 5. So A minus 4b,
Minus.
A minus 5. They both have to be negative, right, to make negative 9? Are you guys kind of with me here?
Yes.
I'm going through here a little bit quickly to show you something at the end.
So.
On the bottom, I got to make 12 and make negative 7.
Minus 4, yes. Minus 4, minus 3.
11. Now notice the last one is division, right?
No, yeah.
Flip it.
So flip it. So on the bottom, I'm going to put that thank God problem, the a plus 5b, a minus 5b, the
A minus.
a squared minus 25b squared.
Right.
I flipped the last one, so that's on the bottom now.
A minus 3b.
Good, and to make 9 and add to be negative 6, it's got to be 3 and 3. And they both have to be negative. So I flipped the last dude and factored the hell out of everybody else. And now you just go to 10, right? So let's see, these go off right off the bat. These go. What else we got? Yeah, here's a minus 3b, and A minus 5b, A minus 5b, right? So here's my point finally. And that was not that hard a problem because all of those had a 1 in front. So they're all pretty decent, or they were little squares, right? So here's my point. When you go to write this out, do not multiply these back out. So this is alive, right? This is alive, this is alive. I can just hear some of you guys talking, I don't have a clue my math teacher's talking about some killing things. Writing the survivors down, what the hell, what kind of class? But you guys see that those are the things that are left. And I don't waste the time and multiply back out. It's better just to keep them factored because you can see that that's why you stopped here. You stopped here because nothing else cancels. No need really to factor back out. It would all depend on what you would do next. And what do we do next? Nothing. So I just stop. So don't waste your time while multiplying it back out. It's just a waste of time. Just leave it factored so you can see nothing goes.
Cool.
Cool. Now, you know me. Here's a little preview.
Of what?
The next section.
6'4"?
Of what? Of the summer blockbuster movies.
6'5"?
That'd be a lot better.
6'6"?
Six.
No.
4.
Fraction action?
So that's all there is here, buddy. Oh, good. Still going.
4 minutes.
All right.
3.5.
What do you guys
Is that the title?
think
Summer
about?
Blockbuster Fraction Action. Jeff, is that the title of Summer Blockbuster you're going to show us? Fraction Action?
7 over X
Sure.
plus 3.
I don't know why they turned that down. It's awesome.
X squared plus 9?
No, come on now.
X squared plus 10.
No.
7.
X plus
6.
3 of these plus 4 of these is 7 of these.
X plus 3.
Right? When you add or subtract, the bottoms have to be the same. They don't change at the end. Because you really have like terms. 3x plus 4x is 7x. And when I said x, I really meant over x plus 3, but it's the same idea, right? That's why you need like denominators, so you make them like terms. So what do you do when you have
You have to break it up.
That's 4 is going to be
Factor.
4 plus, X plus 3, X
X minus 3.
good? So again, I said that all of chapter 6 is all about factoring. And why would you do that? You can't tell what this guy's missing unless you know what this guy's got, right? Sort of like here, if I had 1/5 plus 2/15. 2/15? All right.
3 times 5.
What's he missing?
He's missing
10.
He's missing a 3.
Yeah.
Because that's got a 5 times 3. He needs a 3, doesn't he?
315.
And why do we not have to break this up? Because we know what 15 is. We don't have to really write it for ourselves. I know he's missing a 3 because I know what 15 is. Here, do you know what extra minus? Yes, you do, but you should write it for yourself, right? You have to take a second and what do you get when you factor this?
X plus 3 and X minus 3.
So what's this guy missing?
X
It
minus
makes it
3.
minus
I
3.
want everybody with me on this. It's that simple. This stupid section is just so crazy easy if you can factor. If you can't factor, all of chapter 6 is going to be
Don't you have to
impossible.
multiply it by the numerator and the denominator?
Exactly. So the bottom is missing an X minus 3. The only way to make it legal is to multiply the top also.
X minus 3.
And distribute.
Now, aren't they the same denominator? So yeah, you can distribute. What do you get? You get 3x,
Minus 9.
3x minus 9 plus
4.
4 over x plus 3x minus 3.
That's good. That's done, right?
So how do you make an LCD then? You break down what you can. You give everybody else what they're missing.
Right.
That almost seems too easy. It feels like you're cheating, but that is the way it is, period. Don't make it harder than that. And then here I get 3x.
minus 5.
Yep. And can I reduce anything?
No.
No.
Good. The top won't factor, so I can't cancel anybody out.
Problem's done.
Yeah. So that's section 6.4. They can't make it. The only thing they can do to make section 6.4 harder is to give you harder things to factor. Ooh. Right? The idea doesn't change. All right. That's enough.
Freakiness.
That's enough for
That's enough for today.